Assalamualaikum warahmatullahi taala wabarakatuh, and very good day to my panel 1 and my panel 2. My name is Said Muhammad Shafiq bin Said Muhammad Junus. My meeting number is B09Y810107. I am for 4BMMA1/2, and my supervisor is Dr. Muhammad Ilman Hakimi Chua bin Abdullah. And I am from Faculty of Mechanical and Manufacturing Engineering Technology. And today I would like to present my bachelor degree project, and my title for bachelor degree project is developing lightweight 3D printed backpack with internal geometry for low friction and wear. This presentation consists of 5 chapters. First chapter is the introductions, second chapter is literature review, the third chapter is methodology, the fourth chapter is result and discussion, and the fifth chapter is the conclusion and recommendation. Brakes are the key element in the braking system of your vehicle, and they play a major role when you press the brake pedal in order to stop your car. It converts kinetic energy into the thermal energy throughout the frictions. Due to this contact, friction is generated by the way the driver steps on the brake pedal. The greater the friction, the hotter it is, the lower the brake system efficiency. Problem statement. Lifetime of the brake pad is always a major issue for every car user. The shape of the brake pad cannot be optimal because the economic compromise and engineering factor, and thirdly, the frictions on the brake pads may be reduced by optimizing the geometry, and the brake pads may increase the life expectancy. And this project will be analyzing the 3D printed brake pad in terms of performance. Objective of the project consists of three, which is the design. Is to design and analyze the lightweight 3D printed brake pad using ArcCATIA software. A second objective is to fabricate the lightweight 3D printed brake pad using the SLS machine. The third objective of this project is to analyze the performance of the lightweight 3D printed brake pad in the solid software. Brake system. A braking system purpose is to slow down and stop vehicle movement. Friction is the resistance to the movement exerted by two objects against one another. In the vehicle control, there's two types of friction: kinetic or the moving friction, or static friction and static friction. In the modern automotive, there's two main types of brake system. First is a drum brake system, that consisting in the pushing outward brake shoes mounted inside the drum against the inner surface of the drums. And the second is the disc brake system, which is consisting the two push brake on the disc. Brake system operation. This video will show you how the disc brake operation. And this video will show you how drum brake operation. Types of brake pad. There's many types of brake pad, such as the semi-metallic, ceramic, non-asbestos organic, and the low metallic non-asbestos organics. Design and developing by using CATIA. General sketch for model. Before designing the brake pad, the proper parameter, it must refer to the brake pad first. The CAD parts were designed to give a clear picture on what parameter need to be changed in order to reduce friction by using rear brake pad from 1996 Proton Wera sedan. And then we go to the part design of the model. Traditionally, a brake pad is made up of two distinct components are joined together in a single unit. Reflection materials and the brake pads are considered in one component or in one part in these CATIA parts. These components require a certain design to be technologically and environmentally compatible to avoid a failure. Fabrication of the model. Using SLS 3D printed, the printing process is a 3D wheel build powder bed heats the powder just below the raw materials melting points. They make it easier for the laser to raise the temperature of specific regions of the powder bed while tracing the model solidified parts. The next process is cooling. The blue chamber inside the 3D printer needs to be cooled slightly inside the on outwards. After printing, they are to ensure optimal mechanical properties and to avoid squeezing in parts. The exact cooling rates of each part is influenced by the number of factors, making it difficult and predict and measure. And the last step of the preparation is the post process. After completing a printing job, remove the complete parts to the build chamber, separate them and clean them to excess powder. Typically, this process is carried out manually and by cleaning station using compressed air and media blast. SimSolid software. SimSolids allow the quick simulates various design possibilities under the actual situations, and this individual testing improve the quality while reducing the cost of various prototypes, physical testings and reworks. SimSolid allow for the fast iteration on the full feature assembly design. Of F constant for SimSolid analysis. SimSolid software is used for the primary features of analysis in order to achieve a better result. SimSolid performs a structural analysis for the fully featured CAD assemblies in a minute. It does it the way geometry preparations and meshing, the two most consuming labor-intense and error-prone tasks. Below OCOF and 3D printed ABS instructs was linked to the contact stress distribution pattern, which is prevent wear during the braking. COF or coefficient of friction values for pins for solid square rectangles and circles and triangle range for 0.3 to 0.33 to the 0.442. And this is a table of the coefficient of friction that was given. Effect of different geometry to the COF. In this simulation, the different geometry pattern has been applied toward the surface for each brake pads. As a result comes out, it gives different value of normal traction between the brake pads and the disc. Different amount of the traction given different performance of a braking in terms of frictions and wear. As you can see, this is a result of the simulation for all the patterns, include the solid patterns. The data that illustrate the stress distribution indicate the solid brakes pad, the rectangle brake pad, triangle brake pad, square brake pad, and circle brake pad samples. The color red represents the highest stress location, while the color of greenish indicates the moderate stress and the color of the blue indicates the lowest stress location. The geometry has the effect of the both affinity element analysis result and the coefficient of friction. Different geometry patterns give a different result of traction. The brake pad with the rectangle geometry pattern has the highest amount of the traction, which indicates the brake have the worst traction compared to others. As the data given, the rectangle brake pad has the more red spot that indicate the highest, more stress, and less blue spot indicate the less stress. SimSolid simulation consists of structured non-linear, which can give data of the displacement magnitude. Displacement-based analysis is engineering disciplines that focus on calculating a structure displacement fields. When the solid deformed due to external stress, all of the points is a structure shift. Red color represents the great displacement, whereas blue color represents the smallest displacement. As you can see, this is a result of the solid patterns, and this is the result for rectangle patterns, and this is triangle patterns, square patterns, and last but not least, circle patterns. The maximum displacement, which is indicated by the red color, occur many spots at the outside of blacking plates. The solid geometry has the redder spots to be appear compared to other geometries, this means that the displacement of the solid geometry was greater than other geometries. Results of all displacement simulations show that the circle geometry has the highest amount of displacement, which is only mean that the circle geometry has a more tendency or possibility to be failed, and the solid geometry has a tendency to be failed as it has the lowest amounts of displacement. The next simulation result is a Von-Mises stress. Von-Mises stress is a value used to determine whether the stress exceeds or fracture of material. It is commonly used to ductile materials such as metals. The material will be yield if the Von-Mises stress under load is equal or the greater just its yield limits under a simple tension, according to the Von-Mises use iteration. And this is result of the solid Von-Mises stress, and this is rectangle, and this is triangle, and this is square, and not last but not least, this is circle patterns of the Von-Mises stress result. In von Mises simulation, the result was different from displacement magnitudes. It is because the data shown that the red spot that represented the highest amount of von Mises was at the bright disk instead of bright pads. Most of the affected area was the greenish and the blue color, which is a moderate and low value of the von Mises stress. As you can see, the rectangle pattern has the highest amount of von Mises stress in the megapascal. It is an average of maximum von Mises stress, and the solid geometry has the lowest value, which is indicate that solid geometry has a lower chance of to be failure of OBL. Last simulations of the SimSolid is the max shear stress or the maximum shear stress. In the maximum stress, a ductile material fails or yield when in the maximum shear stress equals or exceeds to be shear stress at the yield point. The maximum shear stress at which ductile materials can be fail represented by red color, while minimum shear stress is represented by the blue color. As you can see, this is the result of the solids max shear stress, and this is rectangle, and this is for triangle, and this is for square, and like balance this is the circle patterns for the max shear stress. In this simulation, maximum shear stress was represented by as a red color, but the same like previous simulation, the most shredded area wasn't formed by red pad, but they had the bright disk. This is because the simulation is detected the most area affected when it was rotating a bright disk. They produce maximum shear stress more than the bright pads. The bright pads more likely grayish and a blue color, which indicates less value of the von Mises. If you come for rectangle geometry, where the solid geometry has the lowest value of the maximum shear stress, and the highest max shear stress value is from the rectangle geometry. Product readiness can be very crucial parts after all the process in making of those products. Some application might be good at certain situation, so that the parameter must be set or differentiate the compare in kind of product. Given the scale from 1 to 5 to representing the performance of the printed black pad, scale 1 indicate the poor performance and 5 is excellence. The solid geometry can be represented as kind of real black pads, and with other geometry applied toward the surface. Solid geometry is dominance of the most simulations, but solid geometries called scale 2 is a normal traction, which is other geometry has have the same performance if a solid geometry. The square geometry has a very outstanding performance as the example as good scales more than other samples, which is mean that square geometry was the best geometry compared to other. Rectangle somehow consists of 3 bad results of performance that maybe are the most not relevant geometry to be applied on the black pad. We move to the potential applications. This method apply patterns on the black pad surface as potentially can be used as producing real black pad methods. At the early stage, this product has a potential to be applied to small vehicles that only can achieve top speed, let's say not more than 30 km per hour. For example, motorized wheelchair, and also a potential to make throughout the industry the focus of braking mechanisms. There's some product improvement for this. This product can make more improvement in terms of adding geometry patterns such as hexagon patterns. Hexagon patterns are believed to be set as a better geometry other than shape or pattern. For next improvement, printing method of this product can also be upgraded by using SLM printing method, which is as many data were collected and analysis be done, it will give more information compared to each black pads model. A team researcher have been studying how different shapes and size of geometry affects the performance of black pads. According to the finding that the addition of the geometries toward the surface of the sample size affects and change of parameter structure. Some of the geometry black pads were printed but not in the optimized condition as expected. This is simplistically because the application was made by nylon is different from real black pads. And the combination of all the future development. will all data the project can be evolved. It is some suggestion or the this project in the future. First is to conducting real physical testing to SLS throughout any machines or can be tested as a real bread pad. Okay, second is further research or the slot of chamfer designs to be added with a geometry applied at the surface of the bread pad. And last but not least, considering new type of material or some fabrication methods. Okay, that's all for me. Thank you very much for giving me time. I hope that you have a very nice day. Thank you for watching. Don't forget to like my video. And Assalamualaikum warahmatullahi wabarakatuh.